Hello friends, this video will be giving you an idea how to estimate the conditional probability of x given y and y given x for a two-dimensional case of a discrete random variable. In many of the cases where we will have to estimate x given y or the conditional probability of y given x, then the concept of marginal probabilities can be used for. Now let us see how to effectively use the marginal values to estimate the x given y and y given x, that is the conditional probabilities values. Now if we have to find the conditional probability of both x given y and y given x for the following problem. X varies as 0, 1, 2, y varies as 1, 2, 3. We have the probabilities Pij to be filled over there in the table. We need to recollect that the formula for the conditional probability is going to be of the format A given B. What do you mean by A given B? The probability of B happening A happening provided that B has already happened. Conditional probability of the happening of B given that A has already happened. So this is going to be probability of A intersection B divided by P of B. We need to keep in mind when it comes to two-dimensional random variable, an intersection sign can be replaced with that of a comma. So now the numerator can be replaced and written as probability of A comma B divided by P of B, because we know that intersection means AND operator, comma over here in two dimension also represents the AND operator. So what we will be having is P of A comma B divided by P of B. So if we rewrite in terms of x and y, this is nothing but P of x comma y divided by P of x or P of y. So whatever be here, if it is y in the denominator, we replace it with y, or if it is x in the denominator, we replace it with it accordingly. And now when it comes to the numerator, this is nothing but our Pij value. And what is our P of y? P of y is nothing but the marginal probability functions of our y. So after estimating the probability densities, marginal values of our y, this can be substituted over here and the answers can be estimated for. So whenever we want probability of x given y, then our formula will be Pij divided by P of, this is going to be the P of y. P of y means which is varying, our x is varying, and which is kept fixed, our j is kept fixed. And when we want P of y given x, the second part of our problem, then this is nothing but P of y comma x divided by P of x. But we know that this has to be written in the proper format of P of x comma y divided by your P of x. So A comma B and B comma A are both the same because A intersection B and B intersection are the same. So replace it in the proper format. So this now becomes P of x comma y divided by P of x. So in the format, this requires the marginal probability function of your x. So you can write this as this numerator as your Pij and divided by, this is variations in x. So you will have it as P I and dot. So I is fixed. What varies over here is your j varies, which generates the marginal probability functions of your x. So we will be making use of this formula over here. Probability of x condition y equal to probability of Pij by P dot j, and probability of y given x will be equal to Pij by Pi dot for the estimation of our x given y and y given x. Now let us quickly find the denominators required for the problem. What are the denominators required? The marginal functions. How to find the marginal functions? When we estimate the marginal of x equal to 0, so we want probability of x equal to 0, we want probability of x equal to 1, and we want probability of x equal to 2. How to find them? Just add them up. X equal to 0 is fixed. What varies is going to be your y. So take the variation in y. So it is 3 plus 6 plus 9. So what does it makes it up to? It makes it up to 18 by 72. Now for x equal to 1, add a 5 plus 8 plus 11. So that makes it as 24 by 72. Next, for x equal to 2, add up 7 plus 10 plus 13 in the direction of your x. So, in the direction of your y, which varies, and so this adds up to 30 divided by 72. Now, what we have estimated is nothing but our marginal probability function of the random variable x. Now, this takes care of the Pij quantity. So, this is my Pi dot quantity. Now, P dot j quantity. What is this? This is our marginal probability function of y. Where is our y? Y varies as 1, 2, 3. So, I will be finding what is going to be the marginal probability function of y. So, what is this now? I want probability of y equal to 1, I want probability of y equal to 2, and I want probability of y equal to 3. What is probability of y equal to 1? Which varies over here? X varies and y is kept fixed. So, you add it up along the column wise. 3 plus 5 plus 7. So, what does this makes it up as? This makes it up as 15 divided by 72. Next, for y equal to 2, add up in this way. 6 plus 8 plus 10. So, that makes it as 24 by 72. Next, probability of y equal to 3, add up 9 plus 11 plus 13. So, it gives me 33 by 72. Now, we are ready with the marginal values, and now we can move on to find what is the variation of x conditional probability of x given y and y given x. So, once the marginal values of x and y have been evaluated, we can quickly move on to estimate the conditional probability. Now, the conditional probability of x given y is x being fixed, y varying as 1, 2 and 3. Recollect again one more time, the formula for your conditional probability is A condition B equal to probability of A intersection B divided by P of B. In which case, what happens over here is x equal to 0, condition y equal to 1, x equal to 0, y equal to 1 by y equal to 1. Now, this is nothing but our P of 0, 1 divided by P of y equal to 1. Where is our 0, 1? Our 0, 1 is x equal to 0, y equal to 1. It is going to be 3 by 72. So, the numerator is 3 by 72 divided by probability of y equal to 1. Where is our probability of y equal to 1? Probability of, this is my y equal to 1, and probability of y equal to 1 is going to be 15 by 72. So, when we divide 15 by 72, the answer for the first condition of probability will be 17 can be cancelled off, leaving you with 3 by 15. Now, moving on to the second quantity, you have x equal to 0, condition y equal to 2. So, this is our element P of x equal to 0, y equal to 2. So, it is going to be 0, 2 divided by probability of y equal to 2. Where is our 0, 2? Our 0, 2. 0, 2 is going to be 6 by 72. So, the numerator is 6 by 72. And what is our denominator? Y equal to 2. Where is our y equal to 2? Our y equal to 2 is going to be here, which is going to be 24 by 72. So, the answer for this will now be equal to 6 divided by 24. The answer for the third quantity is x equal to 0, condition y equal to 3. So, this is going to be P of 0, 3. P of 0, 3 divided by probability of y equal to 3. Where is our 0, 3? X equal to 0, y equal to 3. So, this is our 0, 3. So, it is going to be 9 by 72 divided by the denominator probability of y equal to 3. Where is our y equal to 3? Here is our y equal to 3, and the marginal value for it is going to be 33 by 72. So, 33 by 72. So, this now can be reduced to 9 divided by 33. Hence, the conditional probability of x equal to 0 given y equal to y. So, y varies, and we have estimated the conditional probability that x equal to 0 is given by 3 by 15, 6 by 24 and 9 by 33. Similarly, now we can find the conditional probability of x equal to 1 fixed and y equal to y varying. Now, this is going to be x comma y divided by P of y. So, this is my P of 1, 1 by probability of y equal to 1. Y equal to 1. So, what is P of 1, 1? x equal to 1, y equal to 1. So move on to the next stage. This is going to be 5 by 72. So 5 by 72 divided by probability of y equal to 1. Again, y equal to 1 can be taken as 15 by 72. So this 72 cancels off, leaving you with 5 by 15. And next case, x equal to 1, y equal to 2. So this is going to be our P12 by probability of y equal to 2. So what will be P of y12? P of 1, 2, 1 and 2. So the value is going to be 8 by 72. So you can pick your 8 by 72 and divide by y equal to 2 is 24 by 72. So this value gives or reduces to 8 divided by 24. The last quantity, x equal to 1, y equal to 3. P of 1, 3 divided by probability of y equal to 3. So what is P of 1, 3? 1 over here, 3 over here. So the answer is going to be 11 by 72. 11 by 72 divided by the denominator 33 by 72. So this reduces to 11 divided by 33. The next case, probability of x equal to 2 is fixed and y varies as the various values for y. So now this is going to be P21 by probability of y equal to 1. And now P21, where is our 21? X equal to 2, y equal to 1. So this takes the value 7 by 72. 7 by 72 divided by probability of y equal to 1, probability of y equal to 1 over here. So this is going to be 15 by 72. 15 by 72. So this reduces as 7 divided by 15. 7 divided by 15. Next the value over here. So this gives me probability of 2, 2. What is probability of 2, 2? X is 2, y equal to 2. The value is going to be 10 by 72. So it is going to be 10 by 72 divided by 24 by 72. So this is going to be 10 by 24. So the last value over here, which is going to be probability of x equal to 2, y equal to 3. So it is 2, 3 divided by probability of y equal to 3. So this gives me 2, 3, 2, 3. So the value of P23 is 13 by 72. 13 by 72 divided by probability of y equal to 3. Y equal to 3 is over here, 33 by 72. So the final answer will be 13 by 33. So now we have estimated the conditional probability of x equal to 0, x equal to 1, x equal to 2 for a given value of y. So y can take any values varying between 1 to 3. Now we move on to the second part of the question. What is the second part of the question asking us? Conditional probability of y given x. So it is P of y given x. How to estimate probability of y given x? Probability of y given x is nothing but probability of y comma x divided by probability of x. Now we know that x comma y and y comma x are the same. So first rewrite it of the standard format, x comma y and divided by p of x. What we require over here is marginal values of x. Where is our marginal values of x? This is my probability of x equal to 0. This is my probability of x equal to 1 and this is my probability of x equal to 2. So once I am done, I can start the quantity. The first thing which we require is probability of y equal to 1 is fixed and given the value of x is equal to x. X is varying and y is equal to 1 is fixed. Now what happens? This gives me the value of y equal to 1, x equal to 0 divided by x equal to 0. Apply it in the formula. So what we will have, we can have rewrite the numerator in the comfortable way of x equal to 0, y equal to 1 by probability of x equal to 0. This quantity which is going to be x equal to 0, y equal to 1. What is this now? This is nothing but my p of 0, 1. 0, 1 divided by x equal to 0. Probability of x equal to 0. Which is my 0, 1? Which is my 0, 1? 0, 1. So the value for 0, 1 is going to be 3 by 72. So it is going to be 3 by 72 divided by x equal to 0. What is going to be x equal to 0? X equal to 0 is 18 by 72. So 72 cancels off, leaving you with 3 by 18. 3 divided by 18. The next quantity is probability of y equal to 1 given x equal to 1. So y equal to 1 comma x equal to 1 by probability of, say this is going to be equal to x equal to 1. Sorry for the typo. And so when you have x equal to 1, what will happen over here? So x equal to 1, we rewrite the numerator as x equal to 1, y equal to 1 divided by probability of x equal to 1. This is my p of 1, 1. divided by probability of x equal to 1. What is my 1, x equal to 1 and y equal to 1? X equal to 1, y equal to 1 is going to be my 5 by 72. X equal to 1, y equal to 1, 5 by 72. I write a 5 divided by, what is probability of x equal to 1? Probability of x equal to 1 is going to be 24 by 72. So it will become 5 divided by 24. 5 divided by 24. The last value is going to be y equal to, probability of y equal to 1 given x equal to 2. X takes the third value, which is going to be equal to 2. So it is y equal to 1 comma x equal to 2 divided by x equal to 2. Now this can be written in the standard format by shifting your values x equal to 2 and y equal to 1 divided by x equal to 2. So this gives me p of 2, 1 divided by probability of x equal to 2. So what is p of 2, 1? P of 2, 1. P of 2, 1. So this is nothing but 7 by 72. So it is going to be 7 by 72 divided by x equal to 2. Which is my x equal to 2? 30 by 72 is my x equal to 2. So this is going to be 7 divided by 30. So you give the third value. Now going for the case where you require your probability of y equal to 2 fixed and x varies as 0, 1, 2. So x varying as 0, 1, 2. So x is going to take values x equal to 1, x 0, x equal to 1 and x equal to 2. So when it comes over here, so what you have is going to be the same pattern you can follow. So this is going to be your element P02 divided by x equal to 2. What is P02? 02 is going to be 6 divided by your 18 by 72. So this is going to be equal to, this quantity is going to be equal to 6 by 18. The next quantity will be equal to 8 by 24 and the last value will be equal to 10 divided by 30. And now moving on to the last quantity, probability of y equal to 3, condition x equal to x, y equal to 3. So this is my y equal to 3 and my x varies. So what will be the answer? The numerator is going to be 9 divided by the denominator is going to be 18. 9 by 18. The next value is going to be 11. 11 divided by 24 and the last value will be equal to 13 divided by the value of x. So this is be 13 divided by 30. So now in this way you can complete the conditional probability of both x given y and y given x.